Okay, hi everyone. We're going to do a little video on cumulative frequency graphs, and at the end we'll show you how these connect with box and whisker plots. Okay, so let's start with an example. That's all about the example. Okay, we got 300 apples, and we measured their weight in grams, and there were 10 apples that weighed between 60 and 70, 40 apples that weighed between 70 and 80 grams, etc. Okay, so we took this information then, and instead of just frequency, we made cumulative frequency. So cumulative means adding together, right? Accumulating, putting them together. So at the start, by the time you get to 70, there's 10. But when you go from 70 to 80, you add another 40. So by the time you get to 80, there's 50. And then you add another 70. So by the time you get to 90, there's 120 apples that are less than 90, etc. So add another 80, 200, add another 65, add another 35, so 300. So there are 300 apples altogether. They all weigh less than 120 grams. We take this information now and we put it on a graph. So at 60 degrees, there's no apples. So it's kind of an arbitrary point, but we got to put that there because that's the start of our range here. At 70, there was 10. At 80, there was 50. At 90, there's 120. At 100 grams, there were 200 apples that were under 100 grams. There's 265 under 110, and all 300 were under 120. So cumulative frequencies graph is sometimes called a less than graph. Can you see why? You've probably heard why. Okay, because for example here, 120 of the apples are less than 90 grams. 265 apples are less than 110 grams. No apples are less than 60 grams. 10 apples are less than 70 grams. That's what it tells you. Alright, next step. We look at our graph. The points have changed from green to blue, but that doesn't mean anything. And what we do now is we now join the dots, but we join them with a smooth curve. It's not lines in between, it's a smooth curve going around, and that's important, and you'll see an example of that and why that's important in a second. Okay, so we've got a smooth curve now. Now what we can do is we can take that smooth curve and we can work out the median. So median is the middle number, so it's the 150th apple. And the 150th apple, if we go down now, weighs 95 grams. Now we can take this median and divide that in half again. So we get the first quartile is 84. This number here is 75, because that's a quarter of 300. What's halfway between half, so half of 150 is 75. So the 75th apple weighs 84. So a quarter of the apples weigh less than 84. Half the apples weigh less than 95. 3/4 of the apples, so that's below the 225th apple. 3/4 of the apples weigh less than 103. So that's the power of a cumulative frequency graph. We can easily work out what our quartiles, including the median, which is the second quartile, where our quartiles are. You can also do percentiles and deciles and all sorts of things on this. But there's the median and the upper and lower quartiles. What we can do now, is work out the interquartile range. So this means the middle half of the data. Half the data is between Q3 and Q1. So half the data is within 19 grams of the median. Okay. What we can do now is compare that with our calculator. Now if you put this into the calculator, here I've done it on my old TI-83, and it's not going to give you exactly the same answers because here you can't put in a range and you have to put in the middle value. So I've got 65 where it's between 60 and 70, and 75 between 70 and 80, and 85 means between 80 and 90. So the numbers I get here are slightly different. So the median was 95, previously it was 95. The Q1 was 84, now it's 85, and Q3 was 103. And the calculator says 105, but it's in the same ballpark, right? So the difference is because it's with middle values rather than the interval here, and using values like this would be like a straight line rather than a smooth curve which we see on our graph. So it's always better to do it on a graph, but it also shows you for exams you have to be really careful and really show where your answers came from when you do something like this on an exam. Okay, so you'd have to show this in an exam if you want to get, if they want to accept these values as correct, you have to show where they came from. Okay, one final step is we can make a box and whisker plot from this. Box and whisker plot shows us the 5-point summary. So the 5 points are our median, our upper quartile, our lower quartile, our maximum, and our minimum. So we just draw it straight above or straight below using the same scale and going straight up, and there's your box and whisker plot. What this shows us is that the middle half of the data is quite compact in here, but there's a long stretched out tail for the lower quarter, and the upper quarter is also a little bit stretched out, but not as much as the lower quarter. So the lower half of the data is quite spread out compared to the upper half, but the middle half is quite compact. So showing us that our medians are pretty good measure for an average. Okay, hope this little demonstration was useful and showed you how useful cumulative frequency graphs can be. Good luck, see you again.